Probability in society. After this lesson, you should be able to identify and explain assumptions linked to probabilities and explain decisions based on probabilities. An assumption is something taken for granted, as if it were true. Probability is the likelihood or chance of an event happening. It is calculated by finding the number of favorable outcomes and dividing it by the total possible outcomes. When conducting a survey or experiment, we can use the following formula to calculate probability and make predictions. The probability of an event is equal to the number of times the event occurs divided by the number of trials. We use samples to make predictions about populations. Here's an example. Ruth wants to determine the most common eye color of students. All grade 12 students in 5 of 7 high schools in a city recorded their eye color. A total of 2,300 students were surveyed. The results are shown on the table. From the results, predict how many of the 7,200 students at the local college will have brown eyes. According to the table, of the 2,300 students surveyed, 1,656 students have brown eyes. As a percent, this is 1,656 divided by 2,300 times 100 would give us 72%. So we would need to calculate 72% of 7,200. We usually take the percent as a decimal, so 0.72 times 7,200 is equal to 5,184. That's the number of students that we predict would have brown eyes in the local college. What are the assumptions made about this sample? Are the predictions reasonable? Well, an assumption made was that the high school sample represents the population. However, a college often has many students who come from other parts of the province or territory and other provinces and countries. In this case, the sample could be a biased sample. As a result, the prediction may not be valid for the college population. A biased sample does not represent the population and can make survey results inaccurate. You can be more confident that the prediction is reasonable by revising the prediction statement to include a limitation. If the student populations in the high school and college are similar, based on the results, there are approximately 5,200 college students who have brown eyes. Now it's your turn. Use the information from our previous example to answer the following questions. After each question, it might be helpful to pause the video to give yourself time to come up with a solution, then resume playing to hear the answer and the next question. Number 1, predict how many of the local college students have blue eyes or green eyes. If you predicted that 26% or 1,872 of the 7,200 college students would have blue or green eyes, you're correct. In this case, we would add the number of students with blue eyes, 483, to the number of students with green eyes, 115, to give us a total of 598. Then divide that by the total number surveyed, 2,300, to give us 0.26 or 26%. Then we would need to calculate 26% of 7,200. We turn the percent into a decimal, 0.26 times 7,200 to give us 1,872. Number 2, what limitations might you include to make your predictions more accurate? If you said if the population of the high school students is similar to the population of the college students, then you're correct. Let's review measures of center. Here's an example. Mr. Kurtz gave an assignment worth 30 marks. After marking the first 5 papers, he was concerned the students did not understand the assignment and predicted most students would not do well. Use measures of central tendency to predict the average mark for the whole class. The first measure of central tendency is the mean. Here, we took the total scores of the first 5 students and divided it by the number of students, which gave us a mean of 18. Mean is commonly referred to as the average and is calculated by finding the sum of a set of values divided by the total number of values in the set. Let's take that same data and rearrange it in ascending order, from least to greatest. The median would be 18. Median is the middle number in a data set. It's determined after the numbers in the data set have been arranged in order. The mode is 18. Mode is the number that appears most often in a data set. There can be more than one mode. The mean, median, and mode for the sample scores are 18. Based on the sample statistics, the average mark of the assignment is predicted to be 18 out of 30 times 100, or 60%. Below are the scores for all 30 students in the class. How do the measures of central tendency compare with the data set? Why would Mr. Kurtz's sample lead him to a false prediction? Well, in this case, if we added up all the scores in the class divided by the number of students in the class, we could find the mean, which would be 22. Now let's rearrange the data from the lowest score to the highest score. Here we can find the median or middle number, which would be 22. The mode, or number that appears most often, is 24. Mr. Kurtz assumed that the sample consisting of the first 5 papers was representative of the entire class. This was false. The mean score in the sample population is 60%, but the mean score in this population is approximately 73%. The most frequent score is 80%. It seems he considered too few members of the class. The sample does not represent the population. Now you give it a try. Use the data in our last example to answer the following question. After you've heard the question, it might be beneficial to pause the video to give yourself time to come up with a solution, then resume playing to hear the answer. What if Mr. Kurtz had marked the last 5 papers first? Did they give a more reasonable prediction of the class average? Explain. If you said yes, you're correct. The last 5 papers have an average score of 21.4, which is approximately 71%. This is much closer to our sample mean score of 22 out of 30, or 73%. Let's look at making decisions based on probability. Here's an example. A youth association surveys its 400 members about their preferred activity. There are 100 members in each of 4 groups. The table displays the survey results. What is the probability that a member of any group will choose swimming? Based on this, predict how many of the 400 members will choose swimming. The theoretical probability of choosing any one of the 4 activities is equally likely. The probability of swimming, then, is 1 out of 4, or 25%. 25% of 400 members is 100, so 100 people will probably choose swimming. What assumptions did you make? Well, every activity has an equal chance of being selected, and members have an equal level of interest in each activity. Let's continue this. Based on the survey results, predict the probability that a member will actually choose swimming. Well, the survey results reflect the experimental probability. That means that the probability of swimming is the total number of people that chose swimming divided by 400. So 65 divided by 400 times 100 to give us the percent would be 16.25%. The experimental probability that a member will choose swimming is 16.25%. Now compare your theoretical probability and experimental probability and explain any differences. Well, 25% is greater than 16.25%. The theoretical probability is greater than the experimental probability. Watching movies has the greatest probability. The group of students who answered this survey appear to prefer watching movies to swimming, rock climbing, or bowling. The experimental probability gives a truer reflection of the member's interest. Now you try. Use the data from our previous example to answer the following questions. After each question, it might be helpful to pause the video to give yourself time to come up with a solution, then resume playing to hear the answer and the next question. Number 1, based on the survey results, what is the probability that a member will choose watching movies? If you said there's a 50% chance of someone choosing watching movies, you're correct. The probability of watching movies is the total number of people that selected watching movies divided by 400, which is 1/2 or 50%. Number 2, what is the probability that a member will choose bowling and backpacking? If you said there's about a 3% chance of someone picking both bowling and backpacking, you're correct. In this case, we'll take the total number of people that chose bowling, 64, divided by 400, then multiply it by the total number of people that chose backpacking, divided by 400. That would give us 4,544 out of 160,000, which would be a 2.84%. Here's some key points for review. A biased sample can make survey results inaccurate. A biased sample may result when a large percent of individuals in a population refuse to participate in a survey. When a sample represents the population, you can generalize the results to the population. You can use experimental and theoretical probability to help make decisions based on probability. We hope this video helped you to understand how you can make decisions based on probability. Thanks for watching.